Welcome to the FarmBits podcast.
FarmBits is proudly produced by the Nebraska Digital Agriculture team and hosted by students at the University of Nebraska.
The FarmBits podcast comes to you each week to discuss the trends, the realities, and the value of digital agriculture.
Through interviews with experts, producers, and innovators from across the agriculture industry, we hope that you will step away from each episode with new practical knowledge of digital agriculture technology.
Hello, FarmBits followers, and welcome to another episode of the FarmBits podcast. I'm Taylor Cross.
And I'm Natasha Umezu, and we are glad to have you with us as we start the 2023 season. One topic we'll focus on this season will be the digital tools for pest management.
Today, we were joined by Mike Tweedy, Vice President of Sales at Pattern Ag.
Pattern Ag is using predictive tools to help farmers fight against disease and pest issues.
We hope you enjoyed this episode as much as we did. With that, let's jump into our interview with Mike.
My name is Mike Tweedy. I am the head of the commercial business at Pattern Ag. I came to Pattern about almost 2 years ago now, but I'm 28 years in the industry. I grew up on a rural farm in Southern Illinois, a family farm that was founded around 1800. So agriculture is literally in my roots in my family. Earned a bachelor's and master's degree in agronomy at Southern Illinois University many moons ago, and have worked with large corporations. But for the past 12 years, I've been working in the tech sector in the smaller startup space. And so I've worked in the carbon space, worked in the tech space, but it's where I have a real passion for agriculture is taking these new technologies and helping lead the next agricultural revolution.
Nice to know. And it's always interesting to know about the background about the people. And can you tell us a little bit about the Pattern Ag, how it started, and what is the company?
Yeah, so Pattern Ag, which is based out of Emeryville, California, but our ground footprint is the Midwest. We're solely focused on corn and soybeans right now, but we were founded in 2018 by some technology folks that had worked in other parts of the agricultural industry. And really, if you wanted to put kind of a flag on what we do is we try to help the farmer understand the soil medium that they're planting their seeds in so that they can achieve higher top end yield. One of the things that I became so passionate about joining Pattern was we know so little about the soil. We understand very little about the biology. It's the most complex microbiome on Earth, and so what we do is we use a technology that's been around for over 20 years, but utilized in human health called DNA sequencing, and we look at the biology of the soil. We look at the entire biology. We pick up everything that's there. So you're talking more than 10,000 different species in the soil. And then we look for very specific things, though, very specific pathogens that are responsible for knocking off the top end yield potential of corn and soybeans. And we're really passionate about commodity agriculture because we feel like that's really where this technology is needed. We have fantastic seed genetics that are out there. We've got soybeans that can produce up to 300 bushel, or they have 300 bushel of potential. We have corn that can do up to 500 bushels of yield potential, but we're nowhere near that. The grower's not achieving that. And the one thing that, we understand geophysical aspects of soil. We understand the management practices of what's happening on that farm, but we don't know what's happening in the biology of that soil. So we are looking for those very specific things that are knocking that off. And we're conducting what's called predictive agronomy. So, if you look at how producers make decisions on what they're going to do the next year, it's usually based on intuition and history, but it's not based on what is actually out there. What threats do they face? So we look at what's in the soil and we let them know what threats that they have so that they can make decisions on choosing the right hybrid, the right variety, the right trait, the right seed treatment package, when they need to scout, where they need to scout, and all those things before they put the seed in the ground. Because if you understand what's out there, then you can make really informed decisions on putting the right thing out there.
That is really interesting, and it sounds that Pattern Ag is doing a lot of cool things in the industry right now, and I'm excited to keep talking about those here soon. Before we dive into those specific modeling or predictive aspects, what products does Pattern Ag bring to the market? So
yeah, so what we do is we sample the soil on the growers' fields. We send those off to our labs, and then we look for very specific pathogens. So, we have three panels that they can purchase. One is the pressure panel, which is corn rootworm, soybean cyst nematode, and sudden death syndrome. And we not only tell them what they have, but how much is out there, how many eggs are in that field. Is it Western or is it Northern corn rootworm? We have the performance panel, which has a number of seedling root rot diseases like Pythium, Rhizoctonia, Fusarium, white mold, anthracnose of corn, gibberella stalk rot, things of those natures that that they can use to make decisions on those things that I talked about before on seed and seed treatment. And then finally, we look at the good stuff that's in the soil, from a biological level. What does the mycorrhizal fungi populations look like out there? Do they have a healthy soil? And the way that we define a healthy soil is looking at the pathogen loads and then looking at the beneficial microbes that exist out there. It also informs decisions like, do I need a nitrogen stabilizer in my soil? Or does it look like I'm going to have a lot of leaching? What does my community look like or am I going to need a seed treatment for my soybeans, an inoculant? In many of those types of decisions. And the one that's most exciting to me, especially in the state of Nebraska, is phosphorus solubilizing potential. As you know, we're going to run out of phosphorus to mine in about 60 years. And so there's a lot of interest in being able to mine what they already have on their farms. And, what I was looking at some results this morning from a lot of Nebraska operations, and I'm seeing very low levels of phosphorus solubilizing potential. What that means is we're looking at the genetic pathways that exist in the soil that break that rock phosphorus down. So that, that's obviously a good thing because that impacts how much phosphorus do they actually need to apply versus what they have that could become available in the soil. So those are the three products that we have that we offer to growers.
Oh, this is really, really nice. And actually, I think you could answer one of our questions, that is the importance to have those type of products. Because as you mentioned, with all that data, farmers can predict and also already have some ideas on how to plan for the future season. So I think your answer was really complete. I can say.
Yeah, the key to it too is taking super complex metadata, in which we have the largest agricultural metadata base in the world. We've got over 200 billion data points right now and counting. It's taking that super complex data that has never been done in agriculture and then turning that around into something that is super simple and intuitive to be able to understand what is happening out there. So we use a very, it's a really elegant system that is color coded with, red, yellow, green, which indicates bad, moderate, and good. And then we also show the levels that are there. We tell them what % of their field is at risk. And then we give a very simple, recommendation. We don't recommend products by name. We are product agnostic because that's not what we're selling. What we're telling them is what they need to do, and then they can go choose the products that they want to do. So the key to for us to have a successful product and the growth rate that we're on is taking really complex information and making it so simple that they can just sit down and easily make decisions on what they need to do.
And Mike, do you have some training or practice with the customers to explain how to use the data? There is a specific team that explain to the farmers how to use that?
Yeah, so let me kind of explain how our commercial team is set up. So we have two teams in the field. We create what is called a dealer network, much like the seed industry. Seed dealers sell to growers. We use and so we call those folks trusted advisors. So those could be seed dealers, they could be crop consultants, they could be agronomists. So we contract with them to work with the growers. We have an extensive training program on how to, how to read the results, although it really doesn't require that much because it is so simple and elegant that, my kids could sit down and look at it and understand what's happening. But so that the people that we have going out and contracting with those dealers is called our regional sales managers. The second team that we have is called the customer success team. And what they do is they do that exact training. They troubleshoot any issues that might be in the app. And then they also can help with results readout if there's a particular question. So service after the sale is the responsibility of the customer success team. And we feel that that is a really important feature and a really important team to have to work with those growers to make sure that they're getting everything that they need out of it.
Okay. That is neat. And I've seen a couple other companies, have those service providers and training them to help the farmers since they're already interacting directly with farmers. It's a really good idea. I have a question. Do you think that of the three panels that Pattern Ag is offering and products, is one more important than the other, or is it kind of, farm specific? If a farmer was wanting to start using Pattern Ag, what would be like the first step picking between those three panels?
Yeah, so between the three, the Pro Nutrient panel, which is it's a traditional Malic 3 test that growers can have done on their field that shows them what their nutrient levels are, is one that they're familiar with, right? That's not unique to Pattern. We added that product just because growers asked us to, because they didn't want to send two sets of samples off to other companies. So we added that one, and that's one that's just known. Everybody's been doing that type of testing for over 60 years. Of the ones that are the most important, it would be hard for me to choose. It's like choosing your favorite child, because there's so much value in each one of them. Typically what happens is the growers, you can only get the Pro Nutrient panel if you buy the pressure or the performance panel, because that's what's core to our business. That's what we do that makes us unique. And quite frankly, it gives a much greater depth of information that you can make decisions on. Most of our customers order all three panels. It's well over 50% because our pricing is really, it's very beneficial to the grower. The return on investment is huge. It can be up as much as $150 an acre return on investment based upon the results that they get back. So it's kind of a no-brainer for them to go for all three panels.
This is nice. Good to know about all those things. And so moving to the pest management, can you tell to our listeners what type of disease the products that you have in your company can be able to predict, and in each crop it is possible?
Yeah, so in corn, we can do corn rootworm, which is it's the billion-dollar pest. It's the one that people are so focused on, especially in a state like Nebraska. And we can distinguish between northern and western corn rootworm. So we can tell the grower if they've got extended diapause, which is a big management, big management decision. Am I gonna rotate, or am I gonna stay in continuous corn? Sudden death syndrome and soybean cyst nematode are two huge ones for soybeans. Those would be, there's so much focus on soybean cyst nematode and probably not nearly as much, or that should be, on sudden death syndrome. Because when you have those two pests in the field together, then you've got a synergy that occurs that it's 1 + 1 = 4 in terms of the SDS expression. The other ones that are in the performance panel that are super important, that these are so important because they're so common, but there's no way to identify them until after the damage has occurred. Things like Fusarium, Rhizoctonia, Pythium, gibberella stalk rot, anthracnose of corn, white mold. Those would be additional pathogens that are going to inform decisions like traits and hybrids. So those products, with the exception of white mold, are going to and anthracnose in corn are going to impact both corn and soybeans. So those Pythium, Rhizoc, Fusarium, and they're very, very common. And we're seeing, the thing that's interesting is we can show you that how many of those things exist at the same time in the same field. So you can't think of a pathogen in a vacuum that I've got corn rootworm or I've got soybean cyst nematode. You have to be worried about all the other ones that exist. For example, fields that have sudden death syndrome, brown stem rot, and stem canker. It's about 25% of all the fields have moderate to high pressure of all of those in the same field. So the secret, the real magic behind what we do is being able to tie all those things together and then link that into, what we think the expression could be during the season.
Yeah, and this data that you collect and put all together, disease and corn rootworm together, is really important because, as you mentioned, in the field we have everything, so it's important to have this visual, as you were mentioned. And since you mentioned about the rootworm, can you explain a little bit how the scouting is done? Because you said it's possible to differentiate the Western rootworm. So can you explain a little bit how the sampling is done for this?
Yeah, so I'll kind of walk through the process end to end and explain it, because it is a lot different than what folks are used to. Folks are used to doing physical counts of corn rootworms or physical counts of nematodes. That's not what we do. What we're doing is we're looking for the genes that exist in that soil that we have already mapped and identified and matched up to corn rootworm. So when we take a sample, our typical sampling methodology is we do 10-acre grids, and then we pull 12 to 14 cores represented throughout that entire 10 acres into one composite sample. And that one composite sample is then shipped to Emeryville, California, to our lab. It goes through what's called a homogenization process, where we then extract all the genetic material out into a 1 mil sample. So that 1 mil is the same way, then it goes through the sequencing event. That is the same process that you would sample someone's blood someone's blood to determine if they had a disease or if they had COVID or something like that. We're doing the exact same method. And so we have a representative sample of that entire genetic material extracted into that 1 mil sample. Then that goes through a sequencing event. And so your typical soil sample that goes into a lab, you're generating about 10 data points. We're generating 10 million data points off of each one of those samples. So once it goes through there, then we capture all that genetic material, all 10,000 different species. And then it goes through our bioinformatics platform. So we have code written that has already identified the specific species that we're looking for, and then it not only tells the presence of, but the pressure that exists. So how many are actually there? So we've been able to equate, so much genetic material of corn rootworm equals this many eggs. Now I'll kind of walk through how did we do that, because that sounds kind of unbelievable. So the way that we do that, our validation process was to go out, find hundreds of fields that we did this on, and we would plant what we would consider unprotected corn in that field. So it had no trait that coverage for corn rootworm. There was no insecticide treatment, nothing that was put out. And so we sampled that field, and then we would go back in. We sent researchers in to do corn rootworm digs. And so the way that we would validate the pressure is we do root node injury scores. They do root node injury scores. And so when you get a report back from us, it says, you've got 10 eggs, and that means that you're going to have X. If you do nothing, if you leave it unprotected, then you can expect X injury on your on a root node injury scale. So that's one way that we did validation. The second is, and we do this with soybean cyst nematode, is that we would do the sampling. We would run our samples into the lab. We'd send a second set of samples from the same area into the University of Illinois, and they would do corn rootworm egg counts. And so we've done that with soybean cyst nematode down with the University of Georgia as well. And what we find is our accuracy rating is anywhere from 93 to 95%, which is much higher than doing a physical count in the field. So in short, what we're doing is we're measuring genetic material and then translating that into actual number of rootworm eggs, actual number of cyst nematode. And then when it comes to diseases, we're reporting the actual levels in parts per million of disease inoculum.
This is really unique because as far as I know, the samples that we do, as you said, is counting the number of larvae, right? Washing the roots. So this technique is really unique. And can I ask you just one more thing about the sampling? So how long it take, since you start the sampling and then you can give the data to the farmers about this?
Yeah, in general, so when the farmer goes or the dealer goes into our app, because we have our own app, and they press a button that says this field is harvested, ready to be sampled, we deploy a sampler. We like to have a sampler out there within 5 days, 3 to 5 days. A lot of this is dependent upon the weather conditions, though. As you know, it could be shorter, it could be longer. Once they take the sample, those are 2 days shipped out to our labs in Emeryville. And then we like to turn the whole process around within about 2 to 3 weeks. That time frame can vary just based upon weather conditions and so forth, but it's generally around 2 to 3 weeks. So we want to get that back as soon as we can so that they can make their seed decisions for the next year. We like to have our samplers following the combine out of the field in the fall, but that doesn't mean that we can't sample or do this process throughout the year. There are some growers and dealers that like to do their sampling in the spring, so we can do it in either spring or fall. We do have samples that are also pulled in the summer, although you can't do it the way that we would normally do it because obviously you have a crop in the field and you don't want to be driving across the field. So there are diagnostic samples that are pulled to determine the presence of a disease. If they're starting to see some expression of sudden death syndrome, for example, and they want to say, okay, is it actually here? And then we can turn those results around and say, no, that's actually not sudden death syndrome. It's a different type of disease.
That is really neat. I have a question about that validation process that you briefly mentioned just a minute ago. Is this a continuous kind of validation process? Like you're always continuing that data set, kind of like you just said, you take diagnostic samples too. Does that add to that data set?
Yes, we are constantly validating because the most important thing to us is accuracy and precision in the results that we're turning around because they're going to be used to make decisions. And so we're constantly going through the validation process and we're improving things all the time. So the bigger our data set gets, the more accurate we actually become. So the more data that we get in, the faster our machine actually works, and it even gets more and more and more precise, although there's nothing that's more precise than what we do because we're looking at everything on a genetic level. And one thing that's really interesting, though, is we're constantly adding new pathogens. So last year we added 5 new pathogens. This year, we will be adding one for a really key pathogen for the southern region, which is root knot nematode, which is a really serious problem in the South in soybeans and cotton. And so what's interesting about it is we take biological data and we turn it into gigabytes of data that go into the cloud. And what that means is whenever we turn on a new algorithm for a pathogen or a beneficial, it automatically populates all past reports. So if you'd been doing business with us for 5 years and say, down the road, we turn on a new pathogen or 5 new pathogens, it automatically populates past reports. So you can take a history of actually what has happened on your field over time. And that's different than any other kind of soil test that occurs today.
That is really neat and a great service to the farmers who you've been doing business with for that 5 years. Will those farmers who have been doing service with you for 5 years, do they have to get samples done every year? Is it, like a one-time thing and then they just have this panel every year that might change and update, or you recommend sampling every year?
Yeah, it's an excellent question. So the conversations that we get in with growers, they're typically, they're very accustomed to doing nutrient sampling maybe every 3 or 4 years. They don't do it every year on every acre. Some do, but most don't. But you're looking at micro and macronutrient levels. We're talking about biology here, and biology changes. Your body changes every year. The soil microbiome is going to change every year. In fact, we're getting ready to release our first what's called predictive agronomy report for the 2023 planting season. And we do comparisons of what pathogen loads look like at the beginning of the planting season last year, and then what they look like this year. And so let me give you an example of why it's important to look at it every year. Weather and environment plays a huge determination on especially disease loads for the year. We have done a very in-depth of commercial scale study on sudden death syndrome this year that we'll be releasing in that report. And what we learned is that there is a direct correlation, very strong linkage between where we had high March and April rainfalls and a lot of water standing in fields, and sudden death syndrome and other disease pathogen loads. So what that means is that what happened last spring is going to impact what they're going to be planting into this coming spring. So because of those conditions, it was just right for disease inoculum to grow in those fields during this growing season. And so we were able to determine what those loads are going to look like in the next season. And so your biology is constantly changing. Corn rootworm is another example, since you're in Nebraska, that's super important, because those pathogen loads and locations change every year, because that's determined based upon where the beetle is going to land and lay their eggs. Okay. It's strongly assumed in the marketplace that, and by most growers, that if you're in continuous corn, 10-year, 15, 20-year continuous corn, that I have to plant a triple stack trait and plant that in my, or put that in my corn in order to have corn rootworm protection. And what we're actually seeing is there are many fields, actually the majority of fields, that are even corn on corn, that have no corn rootworm pressure at all. But we're seeing very high levels in corn soybean rotations, even in soybean fields. So just because they like to feed on the corn does not necessarily mean that's where that beetle is going to land and plant and lay their eggs. So that's why it's important, because that pathogen load changes every single year.
Wow, interesting about this. And as you mentioned about, the continuous corn production or the rotation, because this is one of the management for corn rootworm. But since you have all the data, instead of this management for this pest, usually do you, how can I say, do you suggest another management for this pest instead of the crop rotation?
Yeah, we really leave that up to the trusted advisor to make those decisions, because they're on the ground. They know that farm, they know that field. And so what we inform is what is there and what are your options for managing that. Management can be a corn soybean rotation. It could be a trait that you need to purchase to put into that corn to protect it. If the pathogen load, if the corn rootworm load is so high, say 25 eggs and above, then we strongly recommend that they either rotate out for that year, or they're going to have to plant a triple stack trait plus an in-furrow insecticide application. Because we've seen last year, we saw this during harvest, where the corn rootworm levels in eastern Nebraska were so high that the corn went down. The number of eggs and larvae who were feeding on the root systems just overwhelmed the trait package and injured it to the point where when we got some good storms that came through there, a lot of that corn went down. And we've talked to a number of growers that said, I will never ever do that again, because I'm not going to combine corn that's on the ground going 2 miles an hour. So it's important to understand what you're planning into. And but we leave the ultimate decisions up to the trusted advisor, which is either the seed dealer or it's a crop consultant.
Mm-hmm. That is really neat, and that you're able to show that. So you mentioned earlier the simplicity of your panels and the data that is presented to the farmer. So what is some of the functionality that the farmers might see in that web application?
Yeah, so when they go in, they can just type in their operation, and then when their operation comes up, it will show all of the field names on the left side. The pathogens will be on, and the beneficials will be on the top. They can look at the pressure panel, the performance panel, and the pro nutrient. There are tabs for each one of those that they can pull up and look at. And then if they want to just click on a field, they can see everything that's going on in that field at once. And then let's say you look across there and you say, oh man, my corn rootworm levels are high, my pythium levels are high. You can go in, click on that area, or click on that pathogen. It'll take you right down to it, and then you can see the subfield view of the field. So you can see every grid that was in that field. It will tell you on the left side, but it will show you the exact levels of the pathogen that are there. It'll tell you if it's low, medium, or high, and then you can look at the field itself visually, and you can see what the pathogen loads are in each individual grid. So then you can click on each grid, and it will tell you specific detail what's there. Then we also put in other information, information about what the pathogen is and why it's important. We also show each field by field comparison of each pathogen. So which fields have the worst corn rootworm in them, and you can just see it all, in one place. So with just a few clicks, you're basically getting all the level of detail that you would want to see, but you start out at a macro level. So it's a really intuitive platform that our product team has built, and it was designed by growers, by the way. Whenever we were building this product, we went to our dealers, we went to growers, and we asked them, how do you want to see this? And then we give them the opportunity to provide feedback. So this is literally a platform that was built by our customers.
That is very nice. And with all those data, it's possible to predict the yield loss or to tell the economic risk of each pest for the farmers?
It is possible. We don't have that in the product right now, but we will be adding another big layer of data that I don't want to give away right now, that will be able to provide those analytics and provide a prediction on expression and potential yield loss. So that will be a product that will be coming.
What are some of the biggest challenges that you all are faced when dealing with these management predictive tools?
Well, I mean, what we're doing is not trivial. It's the first time it's ever been done here. And so we've got a fantastic data science team that are, building these algorithms, and a fantastic agronomy team and science team that are, combing all of this data to make sure that what we're doing is accurate, precise, and informed. So that in and of itself is a big lift. I call the first 3 years of what we, of our existence was building the machine, right? So now we're perfecting the machine. And so that's a challenge in and of itself. And then just the newness of it, right? Like nobody's ever done this. Nobody's ever done predictive agronomy in agriculture before. And so just getting customers to understand it and then know how to use it. Once they use it once, then they tend to be, pretty addicted to it because they're learning things about their field that they've never known, beginning to answer questions of why this field wasn't yielding very well, why it didn't perform very well. But anytime you're new in a space and you're a new segment within an industry, it's always a super big challenge.
Yes, that is true. And as you mentioned, it's something new even for the farmers. So it's a challenge to get the trust of the farmers as well to use those type of tools.
Yeah, it is. I mean, building trust takes time, and you're going to stumble at some point. And what we try to do is we try to give them the best experience possible. We try to build the best product that they can utilize. And I said this before at the beginning, but I'm super passionate about bringing in the next agricultural revolution, which is understanding the soil and helping the growers make the right decisions. So yeah, it's hard, but if it wasn't hard, then everybody would be able to do it, right?
Yes, that is true.
Yeah.
And since we are talking about, this new tool, something that nobody was used to use, can you tell us, for you, what you are looking forward in the future of the integrate, using those techniques, the digital tools in the pest management area?
Yeah. When you look at technology in agriculture, there's a lot of great stuff out there, but it's pretty disconnected. Like there's not a common thread between, drones and satellites and all the other, really cool management tools that are out there. When we link those things together and we can provide predictive insights as to what's going to happen, and then use the existing management tools, things like drones, My John Deere, Climate Field View, the equipment that's on the tractors, you can then begin to get a full end-to-end story of what is happening on each field, right? Right now, today, we basically have two chapters. We have chapter 1, which is planting. You got chapter 2, or 3 chapters. Chapter 2, which is the weather that occurred during the year. And then chapter 3, what happened at harvest. Well, there's like 15 other chapters that aren't there. And that is what is happening in that, what was happening in that soil, and then stacking the environmental conditions on there to be able to tell a full, complete story. And so what we're doing is, we're writing those chapters that we can add to that book, so the grower knows exactly what happened, what was going to happen, what happened, and then during the season, and then what was the outcome at the end of the year, which is what is the only thing that matters, is yield.
Yeah, it is important to be able to kind of link all those chapters together. And there's so much data in agriculture that could be of benefit to farmers, and really just to solving all those pieces, make it go around. Does Pattern Ag have any plans or expansion into other crops besides just corn and soybeans? You mentioned cotton earlier. What about like peanuts, potatoes, kind of some of maybe more the southeast area?
Yeah, we will expand. In fact, we're not just expanding in different crops. We've got a partnership now with a customer, or with a retail company in Brazil. So we're expanding internationally as well. And we will be globally available over time. Those things take time, though. In terms of expanding into other crops, yes. The common sense thing for us to do is look at crops that are in rotations with crops that we're already in, so that we can bring that added value. So cotton would be an obvious one. I'm not sure about, the vegetable crops, but we're going to probably stay in more of the commodity market in the very near term. But yes, we will be expanding crops. We will be expanding, and every time you do that, it's not a trivial process, because your thresholds for injury by, something like Pythium in one crop may be completely different, or would be completely different than it is for another crop. So you have to set different validations, set different levels, for those pathogen loads, and then what the expected impact on those crops is going to be. So short answer is yes, and it will happen over time.
That's awesome.
This is great. And so, Mike, that is another thing that you would like to talk about, or something that we didn't mention during this interview?
I think the only thing that you might ask is kind of what is the cost to the grower of doing these, this type of program, and then that gives them a sense of, oh, okay, well, it's not that much. And just FYI, the way that I always explain cost is I don't like to narrow in on a number, because our dealers set the end user pricing. But I like to talk to it in terms of about how much it costs. It costs about as much as a little bit less than a bushel of soybeans.
Mm-hmm.
So a lot of growers can connect the dots and say, oh, okay, soybeans are at $13, so it's a little bit less than $13.
Mm-hmm.
Nice. That sounds good. So a tradition here on the FarmBits podcast is we like to ask for a piece of advice to share with our listeners. So what advice do you have for farmers that are maybe facing challenges within pest management on their operations?
Yeah, I mean, look, that's every field everywhere, right? And my piece of advice is learn as much as you can about what's going on there, so that that can inform the right decisions on what to do. Right. So our tests that are available can tell you specifically if you've got problems in a field, one field is outperforming another field. We can provide a deep, very deep biological view of what's happening there that you didn't know about before. And that information then can inform a lot of great decisions on, types of seed to plant, types of protection that you need to take into account. And then, crop rotation, other crop management decisions. I mean, there's probably 12 different decisions that can be informed on that. So if the growers want to learn in a very deep way what is happening on their farms, or even if they're picking up a new piece of ground that they're going to rent and they just want to know, hey, what can I expect this field to do? Give us a call, and you can look us up on pattern.ag, pattern.ag, and you can locate one of our folks in the field who will set you up with a dealer. If you're interested in becoming a dealer, if you're a seed dealer or crop consultant, you can contact us, and we'd be happy to sit down and have a conversation about what that looks like. But my recommendation for growers, or my coaching, would be learn as much as you can to inform better decisions.
Thank you very much to Mike for taking the time to join this episode of the FarmBits podcast. It's really exciting to hear about the science behind Pattern Ag's panels and product offerings that are supporting growers' management decisions. One of my favorite parts of this episode is probably learning how they're determining what's under the soil surface by their unique sampling and validation process that's able to predict potential pressure.
I also think this type of sampling is very interesting, especially in regards to corn rootworm. It's really neat that they are able to differentiate between types of rootworm, all depending upon the soil DNA. I hope you enjoyed that episode, and we look forward to sharing another digital ag story with you next week on FarmBits.
Thank you for taking the time to join us today on the FarmBits podcast. If you enjoyed this episode, please subscribe to the podcast on Spotify, Apple Podcasts, YouTube, or wherever you listen to podcasts to be informed about the latest content each week.
We welcome your feedback. So if you have comments or questions for us, please reach out to us over email, on Twitter, or in the review section of your favorite podcast platform. Our contact information can be found in the show notes.
We would like to thank Nebraska Extension for their support of this podcast and their commitment to providing high-quality informational material to members of the agricultural community in Nebraska and beyond.
The opinions expressed by the hosts and guests on this podcast are solely their own and do not reflect the views of Nebraska Extension or the University of Nebraska Lincoln.
We look forward to you joining us next week for another episode of FarmBits.